Alright, so this is a review on the Bronsted-Lowry definition of acids and bases. Alright, so according to this theory, in the regions, they call it the alternate theory. Right? It says an acid is a proton donor and a base is the proton acceptor in a chemical reaction. Right? So when we say a proton, all we're saying is hydrogen ion. Right? A proton is a hydrogen ion. Why do we call it a proton and not just a hydrogen ion? Because they mean the same thing, right? So hydrogen has one proton, 0 neutrons, and 1 electron. This is a hydrogen atom, right? When it's neutral, a hydrogen atom. When it becomes an ion, when it forms an H plus ion, right? This plus here comes from losing an electron. So when it loses this electron here, right? When it loses it, it only has one proton now. So it has 0 neutrons, 0 electrons, and 1 proton. That's why we call it a proton. But H plus, hydrogen ion, proton, they all mean the same thing when it comes to the Bronsted-Lowry theory, right? So when you hear proton, think H plus. Okay. All right. Moving on. Right. So also, just a quick review of the Irenaeus theory of acids and bases. So Irenaeus theory said that an acid is any substance that produces or increases the H plus concentration when added to a solution. So for example, HCl, when it's added to a solution, right, it will produce H plus ion plus Cl minus, right? So that was the Irenaeus acid. An Irenaeus base is any substance that produces or increases the concentration of OH minus. So for example, NaOH, right, sodium hydroxide, when it's dissolved in water, it will produce Na plus plus OH minus, right? So this is an Irenaeus this is an Irenaeus acid, and this is an Irenaeus base, according to the Irenaeus definition. So produces OH minus, produces H plus, right? So, and that's how you identify an Irenaeus acid or an Irenaeus base. Just by looking at the formula, you will see that Irenaeus acids, they have an H in the beginning, and an Irenaeus base has an OH at the end, easily identified acids and bases. For the Bronsted-Lowry theory, it expanded on that. So a Bronsted-Lowry acid still has an H plus, right? It still has an H, but a base does not have to be, or does not have to have OH in the formula, right? As we're gonna see right now, right? So an acid is a proton donor, a Bronsted-Lowry theory acid is a proton donor, a base is the proton or the H plus acceptor. Right, so, okay, so simple definition here, acid donates H plus, bases accept the H plus, right? When we say donates here, we're saying gives up, right? Gives up or loses, okay? When we say accepts, we say this means takes away or gains, okay? So it gains, a base gains an H plus, an acid loses an H plus, as we're gonna see. All right, so take this as an example. HCl plus water, right? This will produce H3O plus plus Cl minus. Okay, so when you identify a Bronsted-Lowry acid or base, you look at the reactants, you look on this side, and then you look at what happens after they react. You look at the product. So first you look at the before and then after. All right, so you look at the before, what were they before they reacted, and then look at what happened after they reacted. All right, so HCl here will react with water, right? And when we ask you to identify a Bronsted-Lowry acid or a Bronsted-Lowry base, in the regions they call it alternate acid or base. You look at the reactants. We're asking you which of the reactants is considered the acid, which of the reactants is considered a base, a Bronsted-Lowry base, right? So we're focusing on the reactants, but we're looking at the products to give us an idea of where the proton was lost and which species accepted that proton, right, or the H plus. So let's look at HCl here. So in the reactants, you have HCl. In the products, you only see Cl minus by itself, right? So what happened here? Right away, you will see that the H is gone, was lost, right? Was donated, okay? So right away, you see that it lost an H, and now it goes from HCl to Cl minus. That tells you right away HCl is the proton donor, is the H plus donor, right? And by the Bronsted-Lowry theory, the proton donor is the acid, so this will be the acid. And again, I'm asking you, when you see a question asking you which one's the acid, which one's the base, you're looking at the reactants. We're asking about which one is the acid in the reactant, which one is the acid in the reactant side, and which one is the base in the reactant side. Right. Now, let's look at H2O. H2O here, right, has two H's. Let's look at what happens after. After the reaction, it has three H's, H3O plus. A hydrogen ion was gained, a proton was gained, the proton was accepted by the H2O, so now it's H3O plus, right? So right away, this tells you water is gonna be the Bronsted-Lowry base. Why? Because in the reactants it was H2O, but then after the reaction now it's H3O plus. It gained a proton, it accepted a proton, it accepted an H plus, right? It's pretty simple if you look at it, right? Just look at the reactants, look at what happens after the reaction, right? And in that way you identify which one gained the H plus, which one lost the H plus or the proton, right? So H plus, HCl donates the proton to water and becomes Cl minus. H2O accepts the proton and becomes H3O plus. Therefore, HCl is going to be the acid and H2O is going to be the base. All right. Moving on. Right. So this is just a visual. Right. So you have HCl. It reacts with water. The HCl will donate its proton. It will donate its H plus, right, and gives it to H2O. H2O will accept it and becomes H3O plus. Right, so therefore, since H2O accepted the proton, it becomes H3O plus. So since H2O accepted the proton, it's going to be the base. And since HCl gave away its proton, it donated its proton, its H plus, it's going to be the acid, right? And notice again, I'm asking you, I'm looking only at the reactants, not the products. I'm not asking you to identify which one is the acid in the products or which one is the base in the products, because this is where the conjugate acid-base concept comes in. But just to identify, simple identification, right? You just look at the reactants, look at what happens to them after the reaction. Which one gains the proton, which one loses the proton, which one gains the H plus, which one loses the H plus. Right. So basically, in the Bronsted-Lowry theory, what happens here is the proton is transferred, or the H plus. Okay, the H plus is transferred from the acid to the base. Right. So now let's look at another example. You have HCl plus NH3 producing Cl minus and NH4 plus. Right. So this is wrong. Right. So HCl reacting with NH3 to produce Cl minus and NH4 plus. So in the same way, we're gonna look at the before. Right. Look at the before to identify which one is the acid, and we're gonna look at the after to gives us a clue which one gained the H plus, which one lost the H plus. Right. So again, HCl in the reactants right here. in the products, you will see that it becomes Cl minus, meaning it lost the H. It donated the H. Therefore, HCl will be the Bronsted-Lowry acid, right? NH3, on the other hand, you will see it has 3 H's in the reactant side, but in the product side it's NH4 plus, meaning it gained an H plus to become NH4 plus, right? Right away, this tells you NH3 is going to be the base. Why? Because it accepted the H from the HCl. So the HCl donated its H, right, to becoming Cl minus, and the NH3 accepted the H becoming NH4 plus, right? So HCl is the proton donor, and so it's the acid, and H3 accepted the proton, accepted the H plus, so it's the base, right? Pretty straightforward. Just look at what happens before and what happens after. Look at the reactant side, look at the product side, and it is going to be really easy to identify which one's the acid, which one's the base, because you will see how the species react, which one loses, which one gains, right? Another example here, the first one is H2S. So this 2 here should be a subscript, but I couldn't make it a subscript here. So, but anyway, you have H2S plus CH3 and H2, right, reacting to produce HS minus plus CH3 and H3 plus. All right, so in the same way, we're going to look at it in the same way. You could pause right now to identify which one is the acid, which one is the base. I'm going to go over them. You could try both, number 1 and number 2, right? Take a minute, try to identify them by yourself, and then and pause and watch the answer. All right, okay, so again, here you have H2S. So let's look at the reactant. Let's look at the before, and let's look at the after. So before, all right, you have H2S, so H2S. After the reaction happened, now it's HS minus, right? So look at it. H2S becomes HS minus. H2S lost an H to become HS minus, telling you a hydrogen ion was lost, a hydrogen ion was donated. Therefore, H2S will be the Bronsted-Lowry acid. Okay, CH3 and H2, right, in the reactant side becomes CH3 and H3 plus, right, telling you that a hydrogen was accepted by this species, by CH3 and H2, right? A hydrogen accepted and it became CH3 and H3 plus, right? So since this species here accepted the proton, accepted the H plus, gained the H plus, it's going to be considered the Bronsted-Lowry base, right? Number 2, you have NH3 plus H2O producing NH4 plus OH minus, right? Okay, so the same way here, NH3 in the reactants side becomes NH4 plus. Right away, what's the difference between these two species? The difference is that NH3 gained an H plus to become an H4 plus, telling you that NH3 accepted an H plus, gained an H plus. Since it accepted an H plus or a proton, it's going to be the proton acceptor, it's going to be the H plus acceptor, it's going to be the base. H2O, right, in the reactant side, all right, I'm going to erase because I'm going to be using this one, right? H2O in the reactant side becomes OH minus in the product side. Right away, you will see that H2O lost an H. It donated an H, right? So since it donated the H or lost the H, is going to be the acid. All right, that's pretty much it. When the question asks you to identify which one is the acid, which one is the base, asking you which one is the acid or the base in the reactant side. For the Once we get to the conjugate acids and bases, that's when you have to look at both sides and identify which one is the acid, which one is the base. All right. All right. Let's see if we we have one more example here. Take a minute, try to do this on your own. Which one is the Bronsted-Lowry acid? Which one is the Bronsted-Lowry base in this reaction right here? Okay, take a minute, try it on your own. Just by quickly looking at it, you will be able to tell which one is the acid, which one is the base. All right, so CH3COOH, okay, in the reactant side becomes CH3COO minus. So what happened to this substance here, right? So it lost an H, plus, right? So since it lost the H plus, since it donated the H plus, the CH3COOH will be the acid because it lost the H plus, the H, okay? And what happened to the H? Let's look at the H2O. H2O becomes H3O plus. So how did H2O become H3O plus? It gained a proton. It gained a hydrogen, right? So went from H2O to H3O plus. It gained a hydrogen. This hydrogen was donated by the CH3COOH to the H2O, right? So and the H2O accepted that proton, accepted that hydrogen to become H3O plus. Therefore, the water or the H2O will be the Bronsted-Lowry base. Okay. All right. So this was the brief review of the Bronsted-Lowry theory. If you still have any questions, please ask. And also, you should go back to the test wizard and try those assignments again if you need more practice, because there were a lot of practice on Bronsted-Lowry theory, or the alternate theory as the Regents mentions, instead of the Bronsted-Lowry theory.